Assalamu alaikum. In this video, I am going to demonstrate the application of a programmable logic controller setup. In this setup, we have 4 inputs, one green button, one red button, and 2 sensors here and here. And as output, we have a green light, a red light, a conveyor motion both in clockwise and anti-clockwise direction, and 3 cylinders. We are going to learn the programmable logic controller application with the use of ladder logic diagram. So let's get started. The PLC is connected to our computer, and in the computer we have a software. So in order to execute the program with the help of the PLC, we need to turn on the software. When the software is open, we will have this window. We need to create a project, new project, blank project, then click OK. Next, from this drop down menu, we need to select the 120S and press OK. Let's maximize this window. Here we have several items, arrow, a range, a normally open contact, a normally closed contact. We will mostly use these 2 type of contacts. Then we have horizontal line and vertical line to make connections. Then we have output coil, and finally we have applied instructions. As a first program, we are going to see the application of a normally open and normally closed contact. We want to have a program when the green button is pressed, the green light will turn on, the red light will be always turned on, and when the red button is pressed, then it will turn off. So we will want to have opposite behavior for this set and this set. Before creating the ladder logic diagram, we need to know the names designated to these inputs and outputs. We will learn the name of these 4 items. This is named as P0, this is P1, this is P40, and this is P41. So we will have a normally open contact named P0 corresponding to the green button, and we will have a output coil here, and click this here, and we will name this P40 corresponding to the green light. And we will have a normally closed contact here and name it as P1 corresponding to the red button. And if we recall, we click the previous output coil here right after the P0. So let's see what will happen if we do not click it right here. If we click it here and name it P41 corresponding to the green light and click OK, then we will see a void here. So it is a better practice to click the next item right after the previous item. Now we need to fill this void using a horizontal line here. Okay, now our program is ready. But irrespective of any program, we need to use an end line so that the program know the end of the instructions. So we can have our end line here. So we will need to select the applied instruction here. Then we need to type END, end, and click OK. And we will have an end line here. Now, in order to execute the program, we need to click this icon here, which refers to connect plus download plus run plus monitor start. What it basically do, it transfers the program from the computer to the PLC so that PLC can execute this ladder logic diagram. Okay. So what we can see here, the red light is automatically turned on when the program is downloaded at the PLC. And if we see here at the ladder logic screen, we can see that the P1 has received a blue signal and P41 has also received a blue signal, and there is no signal at P0 and P40. This is how the normally closed contact behaves. when the program is downloaded at the PLC, it is automatically turned on. The close contacts are automatically turned on, and the corresponding output will also be turned on. And in case of normally open contact, it remains normally open, that is, it receives no signal. Now if we press this green button here, then we can see that the P0 will receive a signal, and corresponding to this, the P40 will also receive signal. So let's see this. Now let's press this button here. So at the screen we can see that the P0 has received a blue signal and the P40 has received the signal as well. Now in case of the red button, we see that no pressing is done on the red button yet. The P1 has received signal. Now if we press this red button here, we can see that the P1 will lost the signal. So this is how a close contact behaves. So without any pressing, it will be turned on, and when pressed, it will be turned off. Okay, so this is how the open contact behaves, and this is how the close contact behaves, just the opposite. Next, we are going to learn the series connection and parallel connection of the inputs. In order to write a new program, we need to stop the previous one and disconnect it. Next, we can write new things. We need to get rid of this line, so we can right click here and delete this line, and for future we can use this hotkey here, Ctrl U. Okay, so if we add another open contact in series with this line, we just can click here and name it as P1 corresponding to the red button, and let's download this program at the PLC. For each new program, we need to download the program at the PLC. Now, since normally open contact was used, so no output will be resulted. If we press this green button here, we can see that the P0 is turned on or receives a blue signal. And when we press the P1, we can see that the P1 will receive signal. But individual activation of these two buttons does not result in the turning on of the green light. So we need to press these two buttons together so that the connection is complete and the green light will be turned on. So this is how series connection works. In order to have an output, we need to have input in all the items in series. Now let's see the application of a parallel connection. So we can have a parallel connection here named P1 and connect this with a vertical line here, and let's replace this with a horizontal line, and let's download the program at the PLC. Okay, now in parallel connection, either of these two buttons will have the green light turn on. If we press this button, it will turn on the green light. If we press this button, it will also turn on the green light. And if we press these two buttons together, it will also have the green light turned on. So this is how parallel connection works. We can also have two different outputs in parallel connection. For example, let's have P42. P42 corresponds to the motion of the conveyor. We can have an error here since we didn't stop and disconnect the PLC. So now we can have our desired output here, P42. I repeat, P42 corresponds to the motion of the conveyor. Let's click OK and connect this with a vertical line. Let's download the program at the PLC. Okay, now either of this button will execute the turning on of this green light as well the motion of the conveyor here. Now if we press this button here, we can see that the green light is turned on and the conveyor is moving. If we place this item here and if we press this, then we will have this item moving. Okay. Now let's remove this P1 from here. We need to stop and disconnect the program. Let's delete this line. Now what we want to have P40 to here and connect it with a vertical line. Now in this setup we will see that the pressing of the green button will activate the green light and the conveyor. If we press this green button here, we can see that both the outputs are activated. Now it is not feasible for anyone to hold the green button all day to have these items turned on. Rather, we want to have a program so that we can have these items turned on with a single press of this button, right? And we can execute that with the help of a technique called latching. What latching is, we can use either of the output as a parallel connection to the original input. What I meant to say is that we can use either P42 or P40 as parallel connection here. So let's have an open contact and name it as P42. Click OK and connect it here with a vertical line. Now what will happen? If the if the P0 is pressed, then the P40 and P42 will receive signal and it will continue to receive signal even if the P0 is released, because we have P40 as an input at the left hand side as well. So let's download this program as in the PLC. Okay, so there is no signal currently right now. If I press this button, we will have signal at all points, right? Now if I release this button, you will see that the green light and the conveyor continue to move. Now there is a fault in this program, which is there is no stopping it. We cannot stop this program. Okay, so we need to have a backdoor here so that we can stop the program at our own will. For that, currently I need to manually stop the program and disconnect it, and the backdoor or the off switch, we can execute that with the help of a normally closed contact. Let's have a normally closed contact in this series, and let's use the red button here and name is at P1. Okay, so currently in this setup the P1 will be normally turned on. So after a single press of P0, the system will continue to run. Now if the P1 is pressed, then as we have seen earlier, the connection will be lost at the middle and the whole system will shut down. So let's see. Now the P1 is normally activated, and if I press the green button here, we can see that the outputs are turned on, and if I released, the connection continues to be on, and if I press the button here, the connection will be lost at P1 and the whole system will shut down. Now at the current state, this will act as an on switch and this will act as an off switch. So we can have the system on and have the system off, on, off, on, off. So in this way we can have a on-off switch type output. Okay. Let's get back to our previous program, the very first program we learned. Let's delete this line, and in order to insert a line we need to click Ctrl M so that we have some space here, P1 here, and corresponding output was P41. Okay, so now if we have a normally closed P0 here, what we'll have here? We will see that the P41, that is the red light, will always be on, and the green light will be on only when the P0 is pressed or the green button is pressed. And when the difference is that previously when the green button was pressed, only the green light was on, the red light was not affected. Now in this setup, when the green button is pressed, the green light will turn on and the red light will also turn off. This will turn off not only when this button is pressed, but if we press this button, it will also turn off and this will turn on. This setup is one of my favorite because it have a philosophical message. If we assume that the red light represents bad things and the green light represent good things, so we can say that bad things are constant, and in order to have good things in life or remove bad things from life, we need to have effort. Okay, now for the next program I want to use the sensor inputs, and the sensor inputs will be used differently compared to the push buttons. The push buttons are normally off, and when it is pressed the signal is received, but in case of the sensor the signal is already there. When we have something here, the signal will be lost. So let's see how they work. Now in order to have the sensors, we need to use the normally closed contact if we want to activate them. Let's have this P2. Okay, they are named P2 and P3. This one is P2 and this one is P3. So let's name them P2, and as an output let have the red light here, P41, and corresponding to P3 let's have the green light here, that is P40. Okay, as I said, they will act differently. You will see at the point when the program is downloaded at the PLC. Before clicking OK, let's remind you guys that when we have used the normally closed contact, as soon as the program is downloaded, they are on, but you will see that they are actually off. As I said, they act differently. They are usually activated at normal state, and when they are sensed, they will have a deactivation, and it will in turn activate the normally closed contact. Okay, if I place this here between these two sensors, we will have the green light turned on. So this is how sensor works. They behaves opposite to the push buttons. In the next program we are going to learn the use of relays. So let's get started. Let's disconnect the previous program and delete this line as well. Sorry. Have some new lines. Okay, let's have P0, and as output let's use M1. The letter M corresponds to the relays. We can have M1, M2 and so on. Let's click OK, and let's have our P1 in parallel connection, and let's have a close contact for the relay, that is M1, and we can have an output of P40 on the green light. Let's download the program at the PLC. Okay, so the green light will be usually turned on, and either of the pressing of button will have the output turn off. Okay, so what we have seen here is that, as like in relay race, we have intermediary participants, and the intermediary participant here is the M1, which pass the signal to the output, and it acts as an intermediary. The relays help us execute different kind of requirements during the program. We will see further use of relays in the next program as well. In the next program we are going to learn the use of timers. There are two kinds of timers, timer on and timer off. Timer on acts in such a way that a certain output is turned on after a predetermined time, and in case of timer off, the output is usually on beforehand and it is turned off after a predetermined time. The idea will be clear after we see some illustration here. We want to write a program in which the conveyor will turn on after 5 seconds the green button is pressed. That is, when the green button is pressed, then after 5 seconds the conveyor will turn on and continue to run until the red button is pressed. So we need to relate the motion of the conveyor with the green button using a timer. So for that we need to use the P0 as an input, and we need to use a timer. For timer on we need to use T on, then have a space, then name it with T1 or T2 as whatever you like. Then we need to set the time, and since the PLC counts 1/10 of a second, so if we want to have 5 seconds we need to enter a value of 50. Let's press OK. Okay, so we have this here. Now we want that the output will be on after a certain time, that is 5 seconds. So we will relate this T1 with the P42. Okay, and we want to have a back switch here, so we need to use the P1 as a off switch. So if there is any case, we need to stop it. Okay, so let's see if it works. We will going to have some trial and error so that you can learn through mistakes. So currently here is the signal scenario. The P1 is receiving signal since it is normally closed contact, and the timer has a count of 00 initially. Now if we press this button here, the timer will start counting upward, that is from 0 to 50. Let's see what happens. So if I press this here, you see that the timing is counting up, but when I release it, it goes off and reset to 00. So we see that we need to press this for the desired number of seconds if we want to have the output. So now we have pressed this for 5 seconds. So now we have this output. If you release this, the system again shut down. This is not we want or expect. So what we have learned here, that to activate the timer we need to press the button continuously, and even to keep the timer activated we need to press it continuously. But this is not a feasible solution, right? So we need to have continuous signal for the timer to be activated and to remain activated. So how can we do that? We have learned that we can have such arrangement using latching. So let's use or apply latching here. So we need to stop it and disconnect it here. Let's insert some line here, and for latching what we can have is a relay. So as we said, we need to use relays for different purposes, and we can have relay here, and we need to connect it through a number of horizontal lines and then a vertical line. Okay, I think we are good to go. Now with a single press of P0, the timer on will have continuous supply of energy through the relay, and I think the system will run as we expected. Okay, now if we press it, you can see that the timer is continuously counting up with a single press, and the conveyor is continuously on. The conveyor is continuously on. We can just activate it with a single press of the green button. Now if we want to shut down the conveyor, we can press this button here, and it will not shut down it or shut down it until I keep it pressed. But this is not what we wanted, so we want to have another correction in our program. So how can we do that? We can have another closed contact of P1 here, right? So I think that will solve our problem. So you need to apply your logic as required, because for different complex requirements it is very unlikely that you will have the perfect program in the first try. Okay, now a single press of green button will activate the timer, and the timer will start counting and remain activated after the counting is on, since we have used latching here. So as we can see, the timer is counting up and it is activated right after it reached 50, and it remains on. And if we press this red button here, I think it will shut down the system. Yes, it worked. So again, if I press it, then it will turn on after 5 seconds. We can have this here, so you can see the movement. So it's counting up and wait until 5 seconds, and then it start moving after 5 seconds, and when we press it, the system will shut down. And again we can repeat this. So in this way we can have a timer on. We have learned a very important message here, is that the timer on needs continuous supply of energy to be activated and to remain activated as well. In the next program we are going to see the timer off. The timer off is a bit more interesting than timer on, and we will definitely learn through mistakes. I will not write the perfect program in the first trial. It is for the sake of your learning. So delete this I want to write a program in which when this item is sensed here, the timer will continue to run and it will stop after 5 seconds. So as I said earlier, timer off works in such a way that the output remains on for a predetermined time and it turns off after a certain time. In the previous example, we have seen that timer on is activated after certain time is passed, but timer off remain activated for a predetermined time and it turn off after certain time. So let's connect the timer off with this sensor. Okay, this sensor is named P2, and as we have learned earlier, we need to use normally closed contact for the sensor. And let's connect it with timer off. We need to type T off, then space, then just give it a name. Let's give T2 here, and let's type 50 for 5 seconds. Okay, now let's relate this T2 with our conveyor. So the conveyor will remain turned on for 50 seconds and it will turn off after 50 seconds is passed. Okay, so before that I need to illustrate one thing, that how timer off acts. Okay, so we have seen that timer on needs continuous supply of energy, right, to be activated, but we cannot have this same setup here, because if we give timer off a continuous supply of energy, it will not start counting down. So let's have this here. If I put my finger here, you can see that it starts at 50, where in case of timer on it starts at 0, count up and go to 50. But in case of timer off, it starts at 50 and it will count down below and reach 0. But the interesting thing is, when I have a continuous supply of energy, it sticks at 50 and do not start countdown. So it will have a faulty output, because the conveyor was supposed to stop after 5 seconds, but it has been running for a pretty long time. Okay, so when I release my finger, it will start countdown, you will see, and it will turn off after a certain time. So what we see here is that it needs a single pulse of input to be activated, and if we keep the signal continuously, then you cannot have a desired output. You just need to have a pulse input. Okay, so let's have our program here. So put it here, so it will turn on and it will continue until 5 seconds is passed. Okay, there we go. So we can repeat this again and again. So I am repeating this. If we have our finger here or keep the item here in hanging position, look, the signal is not counting down. So we cannot have a continuous flow of input in such scenario, or in case of T off or timer off. We need to have a single pulse or a single press of input to have a perfect execution of the timer off. So the basic difference is timer on needs continuous supply of energy, but timer off needs a single supply of energy or a pulse energy. And the thing is, it will not, timer off will not activate it until it receives the final energy. It's not like that when the PLC receives the program, the P42 is on. No, it's not like that. It does not work like that normally, close contact. Rather, it is activated when it receives just a pulse of energy, and then it is turned on, not like that of the normally closed contact. I hope this clears the idea. Now in the next program we are going to learn the counter. The PLC is capable of counting items based on the number of inputs it received. Okay, so I need to delete these lines. Okay, so the program I want to write is that when the green button is pressed 5 times, only then the green light will turn on. So we need to keep a count of the number of press on the green light. Okay, so let's have our P0 here as input, and as counter we also need to have the applied instruction. We need to type ctr counter, then let's name it C1, and then have a count of 5. Okay, now in case of counter we need to hit a reset button, and we can have our P1 here, which will reset the value at 0. Okay, and let's insert some line here. Okay, and let's connect this C1. It will activate as C1, and when C1 is activated, only then P40 or the green light will be activated. Okay, let's have this program. Okay, first of all we want to see how the counting works. Okay, so we are going to press the green button, that is P0. We are having a blue numbered 0. If I press this once, there is a count of 1. If I press it again, there is a count of 2. Now there is a count of 3. Now if I press this red button here, the items will be going back to 0 from 3. So as you can see here, so this works as a reset button. So I am going on again, 1 2 3 4 and 5. Now with the 5 times pressing, the C1 or the counter is activated and the green light is turned on. And if I press it here, the count will go back to 0 and it will turn off this green light. So this is how a counter works. Let's extend this program into a pretty interesting one. We want to have 5 items in series, and let's place this 2 after certain time. Currently we have 3 items here, and we want to have a program that will turn on the green light until this sensor counts 5 items. Okay, so for that we need to have a continuous running of this conveyor. So what we can do is we can override this with P3, which corresponds to this sensor, and we insert some line here to have continuous run of the conveyor. P0, okay, P42, then as a back switch P1 here. Okay, I think that will do. Up to now we have seen that the conveyor moves in a anti-clockwise direction. We can also have a clockwise motion. For that we need to use an output of P43. Okay, and for that case we need to place these items in left hand side of the sensor, and keep in mind that to have P43 we also need to have P42, because the P42 actually activates the motor and P43 just reverse the direction. So we cannot have P43 without P42. So we are having the P43 here in parallel to the P42, and let's connect this with a vertical line. Okay, let's see if it works. Okay, we are expecting a clockwise motion for the conveyor, so let's see what happens if we press this green button here. Okay, there is count of 1, then 2, and now 3. Okay, I have collected this, and if we press these 2 items, then we will have a count of 5, and that is supposed to turn on this green light. So in this way we can use our ladder logic diagram to have any expected or desired output through proper programming. Thank you.